Hello United and welcome back to Mathemagic. In today's lesson we're continuing with our topic of indices and surds. We're going to actually talk about a bit more about surds. So for today's lesson what we want to be able to do is to perform operations with surds, and by the end of today's lesson we want to be able to add and subtract surds and also multiply and divide by surds. So today it's actually a little bit of a departure, and actually we finished looking at our index laws and we're going to look at specifically that last section that we looked at in our last lesson of surds and working with surds. Now if you remember from last lesson, here's a definition of what a surd was. A surd is an irrational number, a number that cannot be written as a fraction, which is written with a square root sign. And so for example, we looked at this number square root 2. It was a number which we can't write as a fraction, and the way that we know this is that the decimal places go on and on and on and on and on and on forever when we put this in a calculator. And it's written with a square root sign. What we want to be able to do in today's lesson is actually perform operations on these surds. And so what we're going to do, break this lesson into two parts. We're first going to be adding and subtracting surds, and the second part is we're going to be multiplying and dividing with surds. So let's get into it. The first thing that we're going to be looking at is the addition and subtraction of surds. Now, surds can be added and subtracted like algebraic terms. And so this is like collecting like surds. Now, if you remember from algebra, when you have an expression like x plus y plus 2x, what we can do is we can simplify this by identifying the like terms. So here in this case, x and 2x are the like terms, and what we can do is we combine these together, and so this becomes 3x plus y. And so the way that we can do this is we can apply this with surds as well. Surds, we can just treat the square root number but as like one of our polynomials, and we can just add and subtract them looking at the coefficients of those surds. So here, what we want to do when we're adding and subtracting surds, we want to firstly identify the like surds, so which numbers have the same square root. So which terms have the same square root, Then from there, we add and subtract the coefficient of the like surds. So here, just like we do with algebraic terms, we are going to add and subtract them and just deal with the number outside the front. Okay, now remember, surds with no numbers in the front has a coefficient of 1. And so if you see a surd that just sits by itself and doesn't have a number outside the front in front of it, that just means it has a coefficient of 1. Okay, let's have a go at this. So simplify each of the following expressions. So let's have a go at this first one. So here we've got 2 root 5 plus 6 root 5. So here we've got 2 root 5, 6 root 5. They're both like surds. They both have a square root 5. And so what we're going to do is we're just going to add the coefficients in this case, because we're adding. The symbol here is addition. And so we're going to add the coefficients together. So it becomes 2 plus 6, which is 8. And so the final answer here is 8 root 5. Now, another thing I want to make a note here, because I just noticed it, is that last lesson we talked about the number outside the front of our square root. So here, for example, if we had 6 to the power of a third, we would write this as 3 root 6. Now, this 3 is actually written right next to the root symbol, a little bit up above, because it tells me it's the third root. When we deal with these numbers at the front, it's not actually the same thing. Here, it's not this number that we got here is not the 8th root of 5. So this is not the 8th root of 5. This is just telling me I've got 8 lots of square root 5. So this thing here is just 8 lots of square root 5, or 8 times square root 5. And not the 8th root of 5. I've just made a quick note about that. I'm not sure if that's very helpful, but here, listen, I just wanted to make a point of that. Okay, cool. Let's have a look at the next example. Here, we've got square root 3 minus 5 root 3. So here, once again, we've got 2 like surds. They both have this square root 3. And so they're like surds, and we can combine them together. Now here, instead of addition, we are subtracting them. And so what I'm going to do is I'm going to look at the coefficients and subtract it. Now, if you have a look at the first term, there's no coefficient there that is written. So that means that we have a hidden 1. Just like when you see x by itself, that means it has a hidden coefficient of 1. And so here, this is just one lot of square root 3. And so here, when I'm simplifying this, this just becomes 1 minus 5 is negative 4 square root 3. Okay, so here, the thing to note is if you don't see a number outside the front of your square root, there's no coefficient for your root. That just means it has a coefficient of 1. Okay, last example here. Whoop. Let me try and move it again. There we go. Okay, here I've got 3 root 7 minus square root 6 plus 2 root 7. Now here, what we can do is we can only combine like surds. So which terms are like surds? Well, we've got this term here, which has a square root 7, and we've got this term here, which has also got a square root 7. And so these two are like surds. But the other term, square root 6, it doesn't have anything that's alike to it, so we can't touch that at all. So here, all I'm going to do is I'm going to combine this 3 root 7 and this 2 root 7. So here they're going to be plussing together, so 3 plus 2 gives me 5 square root 7, and because of square root 6 I don't have anything to combine it with, I'm just going to be minusing square root 6. And so there we go. That's how we can combine our surds, and we can add and subtract our surds by combining like surds. So here, what we want to look for is surds with the same number inside this square root, inside the root. And so once we've figured out the numbers that have the same number in the square root, we can just add them and subtract them like we would with algebraic terms. The other thing to note here is notice for all of these examples, I didn't change the number in the square root. So here, this was still square root 5. Here, this was still square root 3. And here, this was still square root 7. So we want to also just make sure that we don't change the number inside. We're just changing how many lots of them there are on the outside. So the coefficient on the outside. Okay, so that's how we combine like surds by adding in. So that's how we add and subtract like surds by combining like surds. Okay, so that's the first part of today's lesson. We're adding and subtracting surds. Now, the second part of dealing with surds is multiplication and division of surds. And this is where we actually can change parts of the surds when we multiply and divide. So here, when multiplying or dividing surds, multiply or divide the numbers inside the root. So all we're doing is multiplying or dividing the numbers inside the root. So here, for example, if you see square root A times square root B, or root A times root B, what we do here is just we take the root of A times, oh, hang on, let me write this with the right red, A times B. So we multiply the two numbers. When we multiply surds, we just multiply the numbers inside the surd. So here, this just becomes square root A times B, or square root in algebraic. When we write in algebra, it just becomes A, B. Similarly, when we divide surds, we're just going to divide the numbers inside the surd. So here, this just becomes the square root of, or the root of, A divided by B. Or when we write this in algebra, with algebra, we just write this as a fraction, square root of A over B. And so when you're multiplying or dividing surds, what we do is we just do those operations, but with the numbers inside our surds. So let's have a go at a couple of examples of this. So multiplying and dividing surds, simplify each of the following. So let's have a go at the first one. Here, A, we've got square root 3 times square root 10. And so when we simplify this, this just becomes, when we multiply surds, we multiply the numbers inside our surds. And so here, I'm multiplying that 3 and a 10 and put a square root sign over the top of it. So here, this just becomes square root of 3 times 10, or square root 30. Now here, this step here that I was just showing you the working out that I did to get to the final answer. If you're cool to just jump from here straight to here, that's all good. That's all good. Let's have a look at the next example. Here I've got square root 24, or root 24 divided by root 8. And so here, just like we did when we multiply, when we divide with surds, we actually just divide the numbers inside our roots. And so here, this just becomes the square root of 24 divided by 8. 24 divided by 8 is 3, and so this just gives me square root 3. There we go. When we multiply and we divide by surds, all we do is just multiply the numbers inside our surds or our roots together, or divide them, and that's it. Pretty straightforward. With surds, it's quite nice that way. Now the last one is a little bit trickier of an example. Square root 8 times square root 2. Now we can actually apply the same multiplication of surds law. So here this just becomes square root 8 times 2, which is square root 16. Now unlike the previous two, there's something different about this one. If you remember from last lesson, we talked about how some surds don't end up leaving irrational numbers. So here, square root 16 is an example of that. If I put this in my calculator, square root 16, this will actually give me 4. 4. Because 16 is a square number, and so this is just going to tell me that 4 times 4 gives me 16, which is exactly what I have here. So when you have a square number, you want to be very careful. You want to just make sure that you actually simplify that even further. So that's it for today's lesson, Year 9. Let's just do a quick recap of what we looked at in today's lesson. In today's lesson, we started looking at the operations with surds. And so we did a quick recap of what a surd was. A surd was a number, an irrational number written with a square root sign. And we talked about how we could add surds by combining like surds. So like algebraic terms, we can just look for surds that have the same square root and just add or subtract the coefficients outside the front. And then we looked at multiplying and dividing surds. So when we multiply or divide by surds, we just multiply the number inside our surds with each other or divide those numbers together. So that's it for today's lesson, Year 9. Hopefully that was helpful. And if you have any questions, feel free to send me an email or leave a comment on Google Classroom. I'm more than happy to try and help you. But until next time, Year 9s, I hope you guys are staying safe wherever you are, and I'll see you in the next video. Bye.